3 over 4, which gave us 18 over 16.
I'm going to stop you for a second. I need you guys to listen and look and think, all right? When we are talking about units, what units did her team choose to pack that box with? Did they choose 1-inch cubes, half-inch cubes, 1/4-inch cubes? What kind of cubes?
4.
Do you guys agree?
Yes.
Okay. So when we're looking at fractions and thinking about what numbers mean, what 6 represent? Jesse?
It equals 6/4.
Just the 6. I'm asking about just the 6. What does it mean?
It equals 1 and 1/2.
The 6/4 does, but I'm just interested in the 6. Hang tight. What does the 6 represent?
On the base, it's just 6 quarts cubes.
6 cubes. What size cubes?
4.
So what does this denominator represent?
Size.
The size. So we need 6 cubes. Brayden, what size? 4ths. Do I multiply those denominators together?
No.
No, they're just showing me the size of the cube. The numerator is telling me how many.
Okay. What I realized is when you said that, it's supposed to stay at 4. So we don't multiply 4 and 4. It would be 18 over 4.
Okay.
And then when we have this, instead of it being 16, it would be 18 over 4. And then we would multiply this 18 over 4 with this 18 over 4. And it would give you 324 over 4.
What do you guys think?
I
Look at your method. Do you have one that matches that?
Yes.
What did we do within our learning goal? That's represented there. So looking at the learning goal, what did she show? Lindsay? No. You disagree, Davian? Did she do length times width times height?
Yes.
Okay, she modeled that. If you need to fix something on your solution, fix it, okay? All right, Aniel.
Ours, we did 6, which is the 6/4 times 3 equal 18. And 18 times the other 18 that we had. And so that would equal 324. And the units would be fourths of yep. And so we got our answer as 324 over 4, or it could just be 324 like it's the unit would be fourths.
Okay.
It would be cubed because it's a 3D shape. And then what we did in the learning goal, it was volume equals base times height. Because with the 3 times 6, the 18 would be the base. And then the other 18 is the height. So you did the base times the height, which gave us our answer.
So when his team did the base only and found the length and the width and used it to find the base, what do we call that? When we multiply those two numbers? What is it?
Area.
Area. And then they use the area to do what? Multiply by? The height. All right. Here is your last thing. First, you're going to tell your table groups, and it's going to be your ticket out the door. You ready?
Yep.
I want you to name me 2 different ways that you can find the volume of a rectangular prism.
It's this and this.
Yes. Volume equals length times width times height. Volume equals base.
What do I?
Length times width times height and volume equals base times volume.
Two base.
Length times width times height.
Yesterday and Monday, we had a learning goal about volume. We watched a video. What was in the video? It was a moving truck, right? So what was that guy's situation? What was his problem? Okay, so he was trying to find the volume of the truck. Tell a partner next to you what volume means. All right, stop. What does volume mean? Kimmy? How much we could fit inside. So in his situation, he was fitting some moving boxes, right? What's our learning goal today? Lindsay?
To find volumes of right rectangular presented fractional edge lines.
So before, yesterday and the day before, whenever we worked on volume with the moving truck or the aquarium, you guys had some whole numbers. Yesterday we started talking about fractional parts. You made an aquarium, right? Yes. The parts of your aquarium were all whole numbers. So when I looked at the length of your aquarium, how long was it? 3 units. How high was it?
2 units.
How wide was it?
2 units.
But then I gave you different units, right? You made models with these units. How many of these units make the length of 1 cubic unit?
8.
Careful, just the length.
2.
2. How many made the height? 2. How many made the width? 2. And together?
8.
8 total. I sent you home thinking about 1/4 of an inch cubes. So if these were 1/2 of an inch, I started you thinking on the 1/4. If I had an even smaller cube that was 1/4 of an inch, how many of those 1/4 inches would make the length of 1 inch? David? 4, do you agree? Okay. How about the height of 1?
4.
How about the width?
4.
Do you agree you'd lay them down in the first layer? What would you do on the second prism? Good. So if you find the base of each prism, what can you do with that information of the base to find the volume?
Could multiply it
By the,
by the length and width times the height.
but if I have the base, I've already found some of that information.
So you do width times height and then add them.
Talk about that. All right, so are these prisms the same?
No.
How do you know?
Because they have different measurements.
So if they have different measurements, does that automatically mean their volume is different? So let's say you have your 1 inch cubes and you wanted to pack these. How would you start doing that?
Find the area, the base,
Okay, and if you found the area of the base, what could you do with that to find the volume?
then you times that by the height.
Use that thinking to find those volumes. Okay, so back to me. What did you come up with? Are these two the same volume, Jojo?
No,
How do you know?
because since we're not doing our packing, we're basically doing the packing still. But even though we did know 1 inch by 1 inch by 1 inch, it would take 240 to pack the 10, the 4, and the first box, and then it would take 480 to do the second box. So the difference would be 240.
Okay, so I'm going to stop you there and I want to go over to this side because we had some conversation. I'm going to back up a little bit because you came to the what and the why. over here, what about the how? So when you started thinking of the volume, what was your first step in kind of calculating that? Ariana?
The base.
What about the base?
Well, you could be able to find the base. If you find the base, you would be able to find the whole entire volume of the shape.
How could you use that base to find the volume?
Well, if the base is multiple layers, so it's going to be multiple layers, you'll be able to find one. If you multiply it by the height, you'll be able to find the volume.
Awesome. Do you want to add on to that?
Yeah. So you could just know that it's 4 for the width, so you could 10 rows of 4.
Okay. So if you took 10,
4 rows of
okay. If you did that and had your base, what would your base be?
your base would be 40.
And then if you are going with what Ariana said and using multiple layers, and you know your base is 40, how many layers do you need for the first prism, Jason? So if you have a base of 40 and you're using that to use the layers and you have multiple layers, how would you use the base to find the rest of the volume?
You would multiply it by how many layers you have.
And how many do you have?
6.
Do you guys agree?
I agree.
Okay. So tell me about how you came up with the base.
I came up with the base by, since there's 2 parts in each half inch, so I doubled each number by 2.
Let me clarify for a second so that I understand your thinking. You said there's half in 2. So do you mean can you show me what you mean by that?
What I mean by, like, since each of these squares is a half inch, that I would just double it.
Are you talking about length, width, height, or volume?
I would double it to get the length.
Okay, so you're telling me, just so I make sure that I've got it, that if you have one of these cubes and you're thinking about length, you're telling me I need 2 of these to make one, you would double it.
Yeah.
So, okay, just want to make sure I'm clear. So then if you have 10 inches here and you're using half-inch cubes, how many cubes do you need here for packing?
20.
Okay, how about the width?
You need 8.
You agree?
I do, but I'm trying to figure out if we found the volume of this one and then doubled it, if it would equal the same thing as that, but I don't think it would.
Okay.
I did it, and maybe we would have to multiply it by, I don't know.
Okay, so let me back you up to this part. If you want to go about comparing them based on the cubes, what do you know about this length? If you're packing with 1/2 inch cubes.
That 10 inches is going to be double to 20 inches.
Okay. What about this?
That's going to be double.
Okay, can you find the base layer that way? And once you find the base layer, can you use the base layer to find the volume and then compare? Okay. It's okay, I'll take it.
11.
All right, I'm just going to look for a second as you guys are working so I can kind of catch up.
I didn't do anything yet for the method one because I had to.
You had to what?
She was doing the bubble.
This is a half. One of them, and then one of them would be. Wait, but how'd you get 3/4?
How would you get 3/4?
Oh yeah. That would be 3/4.
Are they? What's saying they have a total of 42 hats? And we know how much Melissa has. Do we know how many hats Rachel has made? It says Rachel has made 8 hats. Do we know how many she's made? No. What is that H?
Then wait till the end to do any.
Well, before we do any math with it, what is it? It's an H. It's a variable, right? So what does a variable represent?
I got the bottom. How many tall? We're gonna need a lot. Yeah, right.
Horizontal was 24 and then
26. Alright, so I'll work on the height.
outside 5 minutes.
Alright,
So I got the bottom. We need 6 for the bottom, right?